So hey all, so we are going to discuss about NFA to DFA. So equivalence of NFA and DFA. So we are going to convert your NFA and to DFA using some method called subset constructions. So main thing we already discussed about what is DFA, what is NFA. So your DFA is nothing but your deterministic finite automata where you will be having only one output state for a transition, and for NFA we'll be having so many output states for your transitions. So comparing this DFA and NFA, you might be finding this NFA is very easy, right? So now what we are going to do is we are going to convert your NFA to DFA. Like what is the constant in your DFA? We said exactly one output state for a transition. That's what we are going to do. First, let's discuss your steps involved in it. It's nothing you need not worry about the heading equivalence of NFA and DFA. So it's nothing but converting your NFA to DFA. So let's first discuss your algorithm, then we'll move on to a problem and we'll solve it. Okay. Next, yes, equivalence of NFA and DFA, converting your NFA to DFA. Okay. So we'll be seeing this steps one by one with an example. Okay. So not worry. Okay. Just consider this. Find the language if needed. Okay, sometimes what they will do is they may not given the exact NFA, right? They might be given a problem statement. First of all, we'll be asked to draw the NFA, and then from that NFA we might be converting to DFA. That's why the first step. Okay, find the language if needed. Then we'll be okay fine, we'll be first from the problem statement. First we'll be writing the formal representation of your language. First we are doing it for NFA because they have given a problem in NFA. So we need to first we'll be drawing NFA, and from that NFA we'll be converting to DFA. That's why the first statement and the first three statements. Okay, this is for NFA. So we know about transition table, right? So for NFA we are going to do that, and then we are going to finally define your NFA, like which is of 5 tuples, right? So what is my set of states? What is my alphabet, what is my transition function, what is my initial state, what is my final states. That's what is defining your NFA. Okay, so how it goes, how will be converting your NFA to DFA? So see here, actually find the transition for, we need to find, okay, from your NFA we need to find the transition for DFA. Right, first how we can start, include the starting state of your NFA. Like you might be having a starting state in all the finite automata, right? So first take your starting state of your NFA Q0 as the starting state in DFA. So the starting state of both the automata will be same. That's what they mean to say. Okay, and then we need to find the transition for all the symbols from Q0. First you will be taking only one state called Q0, that is your starting state in your NFA. That will be the starting state in DFA also. Okay, so we need to get that first state as Q0. Okay, and we'll be finding transition on all inputs Q0. For example, if the alphabet is 0 and 1, we need to find what is the transition on 0, what is the transition on 1. We'll be first checking that one. If your output state is a new state, then we'll be including that one in your DFA. So you need not worry, as we go with the problem, definitely you will be able to understand. Okay, include that in a DFA and find the transition for all the symbols from that state. Okay, so no worries, we'll be seeing that one very shortly. Okay, so we'll be continuously finding a new states. If there is no new states, we can stop. Okay, the state which includes the final state of your DFA is the NFA is the final state of DFA. So from this one, I'm just telling you that the starting state of NFA will become the starting state of your DFA, as well as the final states, which includes the final states in your NFA, will become the final state of your DFA also. Now, as usual, after you received your states, after you finalize your states in your DFA, draw the transition diagram or table, and then you are define a DFA. After that, we might be like to check your validity of your automata, we can check by giving some strings. Okay, and valid and invalid strings to check your acceptance. Okay, that's what we are going to do. We are going to see. Okay, so check this one, like See, we are asking, no, need not worry about this problem. We are asking that we need to first construct the DFA using the substrate construction method. First, we need to draw the NFA and then we have to do with your DFA. Okay, don't confuse with the things like hereafter I'll be giving the problems correctly. Okay, leave this one. Okay, so for, actually we are going to construct DFA. First, let's start with your NFA. Okay, so L is equal to W such that W ends with 0, 1. We are already familiar with this type of NFA, right? So ends with this is your language. If it ends with 0, 1, so obviously we need to have two length 0, 1. Okay, ends with. So I cannot have anything on the last state, and initially will be given any. I can have anything in the beginning. That's why 0, 1 self loop on Q naught. Okay, this is the very basic string as we discussed so many times. This is your very basic string. So ends with everything is ends with 0, 1. These are your example of your strings. So this is the diagram of this is a NFA design. So the ends with 0, 1 and the beginning I can have anything. That's the meaning of this. Okay. So now this is your transition diagram for your NFA. Fine. Transition table. Now we know how to draw the transition table. We have to list out all your states in the left hand side and your inputs on the top. So these are my inputs Q0, Q1, Q2. These are my states Q0, Q1, Q2. So this arrow mark indicates your starting state and this star indicates your final state. Okay, and these are my inputs. On Q0, you can see that on Q0, in Q0 on 0 it goes to Q1 as well as Q0. That's why here marked as Q0 Q1. Okay, on Q0 on 1 goes to Q0. Okay, so Q1 on, like here we don't have any here in Q1 we don't have any transition on 0. So Q1 on 0 it's going to be 5 null. Okay, it's going to be 5 and Q1 on 1 goes to Q2. The same thing for Q0, we don't have any transition, that's why the symbol 5. Okay, so this is up to this NFA. Like we are just defining your NFA by means of your 5 tuples. What are the 5 tuples we know? So what are my set of states? What is my alphabet? My transition function, starting state, and then your set of final states. Okay, this Q is nothing but your set of states. Here we have 3 states, Q0, Q1, Q2, and then your alphabet is 0, 1, and this is your transition function, and this is your starting state, and this is your ending state. From this transition table, I am just going to define your NFA. I hope it's clear. Next. Okay, now comes your process of converting your NFA to DFA. Okay, so what we said actually, include the starting state of NFA as a starting state of DFA. That's what we know, right? That's what we discussed so far. So first have your starting state in your NFA. That is your Q0. Okay, that will act as a starting state for DFA also. That's it. Okay, fine. Now we need to find your transitions. Okay, how to define your transitions? Like how many input symbols 0 and 1. So what is the state I've considered? Q0. So transition. This is a notation for transition function. What I'm going to say is Q0, 0. So Q0 on 0 goes to. So we can see that from the transition previous NFA transition table, it goes to Q0, Q1. Okay, and del of Q0, 1. Q0, 1 goes to Q0. Okay, so far we have considered DFA. We have considered only one state in DFA. No, we don't consider panido. So we have just considered this Q0 only. Okay, so this is only one state in DFA as of now. We just started with the Q0. Okay, so while applying this transition 0, like we are just going to see the transition on the input 0 and 1. On 0, it goes to Q0 and Q1, which is not there in your DFA. So it is marked as a new state. So Q0 and Q1 is not there in your DFA. So it is marked as your new state. Okay. So on 1, it is going to Q0, which is already existing in your DFA. I need not worry about that. So The next state I need to consider is Q0, Q1. I hope you can understand, right? So next state I need to consider, you need to consider the new states in your DFA. Okay, next Q0, Q1. So next state is Q0, Q1 on 0. This is the next state I'm going to consider. So Q0, Q1 on 0. So again, for this Q0, Q1 state, I need to apply your inputs 0 and 1, and we need to check your transition function. Okay, here we have two states. How to find out your transitions? Okay, now what we can do is we can do the union operations here. So Q0 comma Q1 is a one state I'm going to consider like this, and then 0. So what we can do is we can have a union operation here, del of Q0 comma 0 union del of Q1 comma 0. Likewise you can have. Okay, so what we can do is, this is nothing but your Q0 on 0. Check your previous transition table, NFA Q0 Q1. Okay, union Q1 on 0. This is null. Okay, I just have 5. So which is nothing but, you can even write if you want, which is nothing but Q0 Q1. So which is already present, right? I need not worry about already present. Just now we just started exploring this Q0 Q1. It's already existing. We just skip that one. Okay, Q0 Q1 on 1. So again do the same thing, union operation, del of Q0 comma 1 union del of Q0 Q1 comma 1. Q0 on 1 goes to Q0. Q1 on 1 goes to Q2. Okay, so just union, you will be getting Q0 Q2. Now this is a new state that is not present in your DFA. Okay, so we need to repeat the same for this new state Q0 Q2. Okay, fine. So far the first state we just consider is Q0 for your DFA, and the second new state we just consider is Q0 Q1, and now we got another state, another new state Q0 Q2. Okay, so Q0 Q2, again same thing, Q0 Q2, apply your input 0 and 1. So again same union operation, we are getting Q0 Q1, so which is already existing. Next Q0 Q2 on 0 is already existing, we just seen. Q0 Q2 on 1 goes to, again it's Q0. So you can see Q0 on 1, Q2 on 1. Q0 on 1 is nothing but Q0. Q0 on 1 is nothing but your Q0. Q2 on 1 is nothing but null. Okay, I'm going to have 5. So union, you will be getting Q0. So this is the existing state. So what are the states we have confirmed for your DFA is, one second. So what are the states we have just considered for this DFA? First initially Q0, and then Q0 Q1 we just consider, and then Q0 Q2. These are the states, and the final state of your NFA is Q2. So I can, here we have to search for states that contains your Q2. So now it's Q0 Q2. Okay, this is your final state of your DFA. Okay, so let's go to the next one. So these are the states I have: Q0, Q0 Q1, Q0 Q2. Okay, this is your final state and this is your starting state, and try to give the transitions as per your previous. Okay, so see here, Q0 on 0 goes to this one, Q0 on 1 goes to this one. So we have transition for all the inputs. Now this is your DFA and this is your transition table for your DFA. Okay, now so we just say that ends with 0 1 will be accepted by this DFA. So let's check. Okay, let's check with this DFA that we have drawn. Okay, this is your previously we just drawn your DFA diagram, and this is your transition table of your DFA. So now, like, initially we are going to start with your Q0 state, and this is your input string. Okay, this should be actually accepted. From your definition we can say 0 1. Let's apply your DFA and then check. The starting symbol is Q0. Q0 on 0 goes to Q0 on 0 goes to Q0 Q1. Q0 Q1 on 0 goes to Q0 Q1. Q0 Q1 on 1 goes to Q0 Q1 on 1 goes to q naught q2, q naught q2 on 0 goes to q naught q1, q naught q1 on 1 goes to q naught q2, which is nothing but your final state. So this string is accepted. Hope you can able to convert your NFA to DFA. In most of the problems, they might be directly giving your NFA. So you not worry about constructing your NFA in the beginning. Like you just start with your DFA. It's very simple actually. So we are checking for one more string acceptance. So actually from the definition we can say it is not accepted because it ends with 1 0. So we'll be accepting only 0 1. But apply your transition and you can see that this string will not be accepted by your automata. Okay. The second problem. This is your second problem actually. Convert NFA to DFA where your second symbol from right hand side is B. Okay, what's the meaning of that one? What could be the basic string for this? Second symbol. This is consider this is right hand side. Okay, so second symbol from right hand side B. It means that the last before symbol should be B, like this. You can have anything in the beginning. Okay, you can have anything in the beginning like A B A. Anything, and like this. Okay, like this. So first, this is your formal representation. Like you first write your formal representation. L is equal to W such that W consists of all strings where the second symbol from the right hand side is B. Like this you have to write. So see, this is a very basic string. I said, from the right hand side the second symbol is B. So this is your basic string. Okay. So I should have B. So you can see here. From right hand side the second symbol is B. The last before one symbol should be B. That's what the meaning. Okay. So drawing a NFA. This is your NFA. Okay. See, the thing is I can have like, see here, I said the last before. So at the end I can have anything, either BB or BA. That's why here they have given A or B. Okay, that goes to a final state. But this one should be B. That's what B, BA or BB. That's what the meaning. Okay, so this should be like this. And initially I can have anything. That's why the loop on your A with the input A comma B. This is A comma B. Okay, so this is a diagram for your NFA. And from this you can draw your transition table. Like A on A goes to A on B goes to two states, A, B. B on A goes to C. B on B goes to C. C we don't have any transitions. Okay, this arrow indicates start state and this star indicates your final states. Okay, and this we are just defining your NFA here, A, B, C, set of states. This is your alphabet. This is a transition function, starting state and final state. Okay. So we are just going to start for your DFA. Okay. So again, the starting state of your NFA is going to be A. Again, the same thing applies for your DFA. Just take your A as your starting state in DFA. So we need to draw. Okay. We'll be starting with your initial state. Okay. On apply your transition on inputs A and B, and on A it goes to A, so it is existing. I need not worry about this. On B it goes to AB, which is not like in DFA we just started with one state called A. Okay, which is nothing but existing. If I want to consider A, it means what? It is existing. And on B it goes to a new state called AB, which is a new state. So try to include that in your DFA. And now try to find transition on this AB. Okay, AB on A. Okay, how to do this? AB on A. So transition of AB on A, which is nothing but transition of A comma A union transition of B comma A. Hope you can understand, right? We already discussed in the last problem. So which is nothing but on A will go to A union, B on A go to C. So it is AC. This is AC. Okay. Same thing. Now for your AB on B. So del of AB on B. So nothing but again apply your union function, like union operation. A on B union del of B on B. Okay. Now A on B goes to okay, A on B goes to, like we'll be getting ABC. Okay, at final you will be getting ABC, because I couldn't able to see the translation table, that's why I'm just saying the answer. Okay, this is ABC. Again, this is also new state. Okay, so what we need to do is, like in your DFA, so I can say that the states of initially A, and then we got AB, and then we got one more new state called AC, and one more state called ABC. The four states we got. Okay, so we just see, why we are checking this AC and ABC again, we need to explore the new states, still whether we are getting any new states or not. That's why we are checking for AC. For AC, on A and B we are getting only existing state. ABC, on inputs A and B we are getting existing states, so there is no possibility of new states, just we are stopping. And for NFA, the final state is C. So try to include all the set of states that contain C as final state in your DFA. So these are the states we just finalized. Okay, in that one, AC and ABC contains your final state C. So I'll be taking this as a final state in your DFA. C, A, AB, AC and ABC. Okay. These are your, this is your final DFA. You can see you will get all transitions. So you will be getting states for all the transitions in your DFA, and this is your DFA definition. Okay, try to draw this one and check for your inputs. Like you can have, again, for the previous problem we checked, right? Like this, you can check for some inputs. Okay, these are the problems. You can make a note, like problem 3, and this is a listen, this is a different problem. Like they haven't even given the DFA, they have directly given the transition table. It's very easy to convert your DFA. Draw this transition table and try to get your DFA. Okay, I'm not going to discuss this one, like, because you just try to solve on your own. Again, okay.